Okay, so if in the previous, on number 5, we looked at when we used or, we added our probabilities. Now we're going to look at when we use the word and. So in this problem, there are 3 blue marbles, 6 red marbles, 2 green marbles, and 1 black marble in the bag. You choose a marble, replace it, and then choose another one. Now the total amount of marbles will be 3 plus 6 plus 2 plus 1, which equals 12 marbles in total. Now to find the probability of 2 or more events, we multiply them. We add when we say one or the other. But if we have 2 events or 3, when we use the word and or the comma, means that we are multiplying. So let's try to find the probability of green and black marbles. So the probability of green is we have 2 green marbles. So 2 green marbles, I'm actually going to write this as a fraction. So if we go on top of our document and we say insert equation, it will bring us to these little mathematical equations and we can put up a fraction. Therefore, I have 2 green marbles over, 12 total marbles. And we're going to make this a little big because it's very small. That didn't work. It's okay. So it's 2 over 12. And we said we're going to multiply times. And we're going to insert the probability of black. We have 1 black marble. So we're going to insert again another equation. And we need another fraction. 1 black over 12 total. Since we have 2 fractions, multiplying is the same thing as saying multiplication of the numerator. So 2 times 1. Oh, let me put the fraction first, I'm sorry. 2 times 1 over the multiplication of the denominators. 12 times 12. So now I know that in my numerator, I have 2 times 1 gives me 2. And in my denominator, 12 times 12 gives me 144. But we know that this is not a simplified fraction. So we're going to simplify by 2, the numerator and the denominator, because I know that 2 divided by 2 gives me 1. So let me put the fraction again. And the numerator is 1. And 144 divided by 2 is 72. So 1 over 72 is the probability of getting green and black, because there is a 72 total choices. The same reasoning will happen with probability of green and red. So let's insert our equation. We need a fraction. The probability of green, we have 2 green over 12 times, I'm going to insert times and put another fraction. We have 6 red marbles, 6 over the total amount of marbles, which is 12. And now 2 times 6 will be 12 is my numerator. And as we said, 12 times 12 was 144 was my denominator. And we can still simplify that because we can see a 12 common factor for both number 12 and 44. I'm sorry, 144. So if we simplify, 12 divided by 12 gives me 1 in my numerator, and 144 divided by 12 gives me 12 in my denominator. So the probability of getting green and red is 1 over 12. Because there is higher chances of getting green and red than getting green and black, because the denominator is smaller, which makes the fraction bigger. Now, let's look into the probability of getting 2 reds. So let's insert our equation, and we need our fraction. The probability of getting red, we have 6 marbles, which is 6 over 12, times another red. It's again 6 over 12, because we're replacing it. Means that we took a red out. We have 5 left in, but in order to do the second event, we're going to put that red back in. So now we still have, again, 6 red choices over 12. If we didn't have to replace it, that would have been a different story, which we're going to talk about it a little bit later. So we're going to multiply our numerators. 6 times 6 gives me 36. And we know 12 times 12 is 144. And again, we can simplify by 36. 36 divided by 36 is 1. 144 divided by 36 is 4. So the probability of getting 2 reds is 1 over 4, which is even a higher chance than getting green and red, also even higher than getting green and black. And since the numerator is all the same, the denominator is telling that to us. And this was the way we think about it when we were replacing it, meaning that the amount in the bag never really changed. Now, let's think about probability without replacement. So we have 12 marbles again in our bag, and I'm just going to write here so we can have them in front of us. We have 3 blue, 6 red, 2 green, and 1 black. That's how we got the 12. So now we want the probability of getting blue and black. So let's think about this again. Let's put our fraction, because we know every probability is, you have to represent it as a fraction. We have how many blue marbles? 3. So 3 blue marbles, let me put the fraction, over 12 total, times. Now from the bag of 12 marbles, I took out a marble, which was blue. So I'm left with 11 marbles now, 11 total marbles now. So my denominator is not going to be 12 anymore. In this case, it's going to be 11. And I only have 1 black over 11 possible choices in this case, because we already took one out, which was the blue marble. And then we will continue with the multiplication as we normally do. So 3 times 1 will be 3 in the numerator. 12 times 11 will be 132 in my denominator. And we know that we can simplify by 3. Therefore, in my numerator, I'll have 3 divided by 3 is 1. In denominator, 132 divided by 3 is 44. So the probability of getting a blue and a black marble without replacing is 1 over 44. Now let's look at green and green. Let me insert my equation because I need a fraction. Probability of getting 1 green marble. In this case, we have 2 green marbles out of 12. So in my hand now I have 1 green marble. And in the bag, I'm left with another 11 marbles because I'm not putting it back. I'm not replacing it. So therefore, I will multiply it by, since I have one green in my hand, I'm only left with one other green inside the bag and 11 total marbles. So now we can multiply these two fractions. 2 times 1 is 2. 11 times 12 is 132. Oh. And if we simplify this fraction, it gives us 1 over 66. So I can see that if I want to pick both of the green marbles out of the bag, I have a probability of getting it out of 66 choices, getting it once to get both of them at the same time. Now let's try red and blue. Let's put our equation. We need a fraction. The probability of getting red, we have 6 red marbles, so it's 6 over 12. And we're going to multiply it by, we need the probability of blue. We have 3 blue choices still, but because I took out 1 red marble, I'm only left with 11 other marbles in the bag. So let's multiply the numerator with numerator and get 18. Denominator times denominator gives me 132. And if we simplify this by 6, we get 3 out of, 3 out of 22. So to get a red and a blue marble, we have 3 chances out of 22, which is a higher chance than getting blue and black, and even higher than getting both of the green marbles. And again, the denominator tells us that. The bigger the denominator is, the smaller the fraction gets.